Error bars are important in an experiment because they allow you to visually represent the variability of your data. So there's three types of error bars. The first one, for our class, there's three. There's lots more, but we're going to stick to the three basic types. Now the first one's called range error bars. Range error bars show the maximum value, the minimum value, and the average value. Here they've got it listed as the mean. So the maximum is shown on the graph as the top of the error bar, the minimum is shown as the bottom of the error bar, and the average is shown as either a data point in the error bar, or in this case they've got it as a line representing the mean value. So if you were to interpret these error bars, you would say that in 2008 the average value was 5, the maximum value was 6.2, and the minimum value was 3.8. In 2009, the average value was about 4.2. The maximum value was near 5. The minimum value was 3. And in 2010, the average value, or the mean, was right around 5 again. And the maximum value was like 5.3, and the minimum value was maybe 4.6. So that's how you would read those error bars. And I'll talk later about why we care about error bars in the experiment. So that's the first type, range. The second type of error bar that we're going to use in this class is called a standard deviation error bar. Standard deviation error bars show a value that you have to calculate. And we'll talk more about how to calculate standard deviation. But one thing to note here is that these error bars are going to be different heights because the variability of your data that you calculate, called the standard deviation value, will be unique to each group. So if you looked at compact cars and the price of compact cars, a new compact car, the average price was around $5,000. What they've got listed here is the confidence interval. We'll talk more about when we learn about standard deviation. But what they're telling you in this graph is that within the standard deviation value, you had actual data points. So there were compact cars that were sold that were priced as high as around 7,000, and as low as 30-some hundred. This is different from a range error bar because it's not showing you necessarily the maximum and the minimum, but rather where those values fall in terms of your standard deviation away from the average value. So standard deviation is a calculation that we'll learn how to do where you take the average value and you figure out the spread of your data. And so this represents the spread of the data, not necessarily the exact minimum and maximum value, but rather the spread of the data. More to come on that in a future tutorial. The third type of error bar is called instrumentation error bar, and this is probably the easiest one to understand. It shows the variability based on your instruments that you use to measure. So if you're using a scale, in this case they've got error bars in this diagram that run roughly 20 units. So the scale that they were using to measure this, anytime that you put something on a scale and you read it, or you look at something in a graduated cylinder, you're always getting an estimation. Even if it's a digital readout, the machine is estimating based on a specific value. So in this case, the machine estimated plus or minus 20 units. And so we'll talk about how this works with actual lab data as we start conducting experiments in the class. The key to understanding error bars and why we care about them is that they help us discuss the significance of our data. So if the error bars between different groups do not, if they overlap, then that's telling you that there's some shared values in that data. And that means that the data is not going to be significantly different between the groups. So if you have group A and group B, and their error bars on a graph overlap, so if you look here, these error bars overlap between groups 3 and 4 here. Because those error bars overlap, you can say that the data between these groups is not significantly different. There were values in group 4 that went up as high as 90 and as low as 70. And in this case, group 3 had values that, they shared values between 90 and 80. So both groups had values between 90 and 80. represented here by overlapping error bars, which tells you the data is not really different between those two groups. Now, if the error bars between groups do not overlap, then the data may or may not be significantly different. You can't simply use error bars to say, well, these are significantly different from each other. You have to actually carry out statistical analysis. Either you'd have to use t-tests or chi-square analysis to talk about the difference between the groups. But in this case, group 4 and group 6 have very different average values and very different range in their instrumentation values. So it's likely that these two groups are significantly different from each other, but you'd have to carry out statistical analysis to be sure of that.